Now we will find out the expression for the electric field at a point on the equatorial line. We'll proceed in a similar manner. First we'll draw the vector diagram and then we'll try to find an expression for the strength of the electric field. Dipole, as we all are aware, it's a system comprising of two equal and opposite charges separated by a finite separation. This is the center of the dipole. Dipole length is considered to be 2a, right? 2a. It's directed from negative charge to positive charge. Dipole moment, it is also directed from negative charge to positive charge. Now, write perpendicular bisector, that is equatorial line. This is an equatorial line. So suppose this is the observation point where we need to find out the electric field. So our objective is to find out the electric field at a point on the equatorial line due to an electric dipole. Right? The distance of the observation point from the center of the dipole is considered to be r, as was considered in the previous article. Right? So join these two lines. Consider this to be 1 and this is 2. Just we'll consider as per convention 1, 2, nothing else. So at point P we need to draw the vector diagram. At point P, the direction of the electric field due to this charge would be in the outward direction. It's a positive charge. So electric field will be in the outward direction. This is E1. Due to this negative charge, the electric field will be towards the negative charge. Again I am repeating, electric field due to a positive charge emanates. Electric field due to a negative charge terminates. So from positive charge it will be in the outward direction. Due to negative charge, electric field will be in the towards the source charge. This is E2. Now in this case, the length of the arrows representing E1 and E2 both must be equal. Why? Because the distance of the observation point from these two charges are also equal. Therefore the strength of the electric field will also be equal. So basically E1 is equal to E2. Suppose each is equal to E. And what will be its value? It will be formula is 1 over 4 pi epsilon q by r square. Here source charges, we are considering magnitude. Once we represent the vector diagram, we need to consider only the magnitude. So the source charge either plus q or minus q. So source charge magnitude is q. And separation is separation of the observation point from either of these two charges. You can make use of Pythagoras theorem. So it will be r square plus a square, the square root of this. So this is the distance of the observation point from either of these two charges. So on squaring, the square root will disappear, so we'll be left with r square plus a square. So the electric field at point P on the equatorial line due to both these charges will have the same magnitude because point P is equidistant from these two charges. It is equidistant from these two charges, right? Let's find its direction now. Now as you are aware, these two are equal. Now whenever the two vectors are inclined at an angle theta, then the magnitude of the resultant as per the parallelogram law or triangle law of vector addition is given by resultant is equal to square root of a square plus b square plus twice ab cos theta. Let's make use of the same formula. So E equatorial, it is square root of a square over here E, each is equal to E, a square plus b square, again E, plus 2ab cos theta. Theta is the angle between these two. This is the angle. This is the angle between E1 and E2. Now what will be this angle? Now look, these are the two sides which are equal. So we are talking about isosceles triangle. It's an isosceles triangle. Now we are aware of the basic fact. If these two sides are equal, these two angles must also be equal. It is because the angles opposite to the equal sides of a triangle are also equal. So if this is theta, this also needs to be theta. So these are the interior opposite angles. Therefore the exterior angle is equal to the sum of the opposite interior angles. So the angle between E1 and E2 would be 2 theta. Fine. So the angle between these two is 2 theta. So resultant is square root of a square plus b square plus twice ab cos the angle between those two vectors, which in this case is 2 theta. Let's solve it. It will be 2e square. It can be taken as common. 1 plus cos 2 theta. Now again, cos theta can be further modified. Cos 2 theta. It can be written as 2 cos square theta minus 1. So if we substitute this value of cos 2 theta over here, minus 1 plus 1 will get cancelled. 2 cos square theta multiplied by 2e square will be left with 4e square cos square theta, which in turn would give us 2e cos theta. So that's its magnitude, E equatorial. We can substitute the value of E over here, cos theta, its base over hypotenuse, we can get the expression. So let's do it. So E equatorial, it would be equal to twice, substitute this value of E over here, Q divided by 4 pi epsilon R square plus A square. K can be written in place of 1 over 4 pi epsilon. Again, it's your wish. Cos theta, consider this triangle. It's a right angle triangle. Cos theta is base over hypotenuse, so it will be base is A, hypotenuse is square root of R square plus A square. Fine? So what we get is E equatorial, it is equal to 2QA, Q multiplied by 2A, that is the product of charge, and the separation between those two equal and opposite charges constituting the electric dipole, that is known as dipole moment, represented by small letter p. So Q multiplied by 2A, that will represent dipole moment. So it is P 4 pi epsilon and base is same. So the power will get added up. So we'll get R square plus A square to the power 3 by 2. So this is the formula, or rather the expression for the electric field at a point on the equatorial line of an electric dipole. So this is the magnitude. Now we need to find out the direction as well. Okay. Again, we'll make use of the basic concepts of laws of vector addition. As I've stated, E1, E2 both are equal. And we are aware, whenever it is the case of two equal vectors, then the resultant always bisects the angle between them. So these are the two sides of adjacent sides of parallelogram. So the resultant would be given by the diagonal of the parallelogram. And in this case, since these two vectors are of equal magnitude, therefore the resultant would bisect the angle between them. The angle between them is 2 theta, so it will bisect. So this is E equatorial. Bisect means this angle would be theta and this angle would be also theta. So this is the direction of E equatorial. So it is anti-parallel to P vector. P vector is directed from negative to positive charge. E equatorial is directed from positive charge to negative charge. So that is very, very important. E equatorial, its direction is from positive charge to negative charge. So the direction of the electric field at a point on the equatorial line due to an electric dipole is from positive charge to negative charge. That is in a direction opposite to that of the dipole moment. That is in a direction opposite to that of the dipole length. So that's a very, very important point. E axial, it's directed along the direction of the dipole length or the electric dipole moment, but E equatorial, it is directed opposite to the direction of dipole length or dipole moment. Now let's consider a special case. Again, for a short dipole. Short dipole I have stated. In case the dimension of the dipole is very, 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 very small, while the distance of the observation point from the center of the dipole is very, very large, then that dipole may be considered to be a short dipole. In such a scenario, mathematically R is very, very large as compared to A. When A is vanishingly small as compared to R, then A square can be neglected in comparison to R square. So let's consider this particular term. So R square plus A square can be written as R square. A square can be neglected. So if we substitute this value over here, then for a short dipole, we get P divided by 4 pi epsilon. R square plus A square needs to be replaced only by R square. R square to the power 3 by 2. So we'll be left with P over 4 pi epsilon R cube. So this is the formula for E equatorial due to a short dipole. Again remember, this expression or this formula for the electric field at any point on the equatorial line is to be used only when this condition gets satisfied, or we are talking about a short dipole, right? So again, conclusion is, as I stated in the previous article, due to a point charge, electric field obey inverse square law. But due to a dipole, electric field at any point, whether it is an axial point or whether it is a point on the equatorial line, the electric field varies with the distance as 1 by r cube. So that is again a very, very important point. So if you remember, for a short dipole E axial, formula for E axial was twice P divided by 4 pi epsilon r cube. I am talking about in case of a short dipole. So let's find out the relationship between these two. Right? If you divide these two, what do you get? This is a very, very important result for a short dipole. I'm stressing on this, only for a short dipole it is valid. For a short dipole, E axial divided by E equatorial. If we divide these two, we get 2:1. So E axial is equal to twice E equatorial. Only when the dipole, electric dipole under consideration is short.